Okay, this is section 3.3, analyzing graphs of quadratic functions. We actually already know what the graphs are. They're parabola. So, standard form of a quadratic function. So, we're doing functions now, not equations. Recall that the graph of a quadratic function is a parabola. We will look at the standard parabola. We've actually seen it before with one of our basic graphs back in section 2.5 when we were doing our transformations. So, all the parabolas are basically this one moved around, inverted, stretched, and or shrunk. Okay, now, of course, when you're given the expression for the function, there's no reason not to give it to your graphing calculator and graphing it that way. So the basic parabola, f of x equals x squared. Again, we've seen it before. Let's plot some points. If x is 0, I get 0 squared, which is 0, so I have a dot at 0, 0. Then I go to 1. 1 squared is 1, so I have a dot at 1, 1. And if x is negative 1, I have negative 1 squared, which is also 1. So hopefully you see the parabola taking shape. We've seen it before. If x is 2, 2 squared is 4. If x is negative 2, negative 2 squared is also 4. So now I can draw my standard parabola. Again, we've seen it before. Can I remember, all the other functions, or that one, all the other quadratic functions, their graphs are basically that one moved around. This point right here, 0, 0, which is actually the lowest point on the parabola. And if the parabola were upside down, it would be the highest point. That point has a name. It's called the vertex. This is the same graph, only I've gotten rid of the table of values over here. So this point right here, that's the vertex. In my math lab, whenever you're graphing the parabola, it always wants you to plot the vertex. And then I'm going to show you when we start graphing how to get one other point. The problems in my math lab always want you to plot the vertex of the parabola and one other point. And as you're trying to find that other point, you can actually see the parabola taking shape. And of course, by hand, we would want the vertex and two other points. Standard form. Okay, standard form. Definition. Remember, the standard form of a quadratic function is f of x equals a times x minus h squared plus k, with a not equal to 0. Remember, you have to have the x squared in order to make it equal to 0. Notice it is x minus h, not x plus h. So when you actually see numbers, h will be the opposite of what you see, k is exactly what you see. That should remind you of our translations back in section 2.5, that what was with x was the opposite, and what was with y was the exact same thing that you saw. So properties, again, properties of the standard form. So the vertex is at hk, always, hk. It's labeled hk, just like the center of the circle was hk, the vertex of the parabola is hk. Number 2, the axis of symmetry is x equal h. The idea of the axis of symmetry is if you fold the parabola along that line, and it is a vertical line, x equal h, the left and right side of the parabola will coincide. That's where all parabolas have symmetry, along their axis of symmetry. Be aware the axis of symmetry is sometimes called the line of symmetry. And be aware it is an equation. It's x equal h. If you just plop down h, it's going to be wrong. Now, a lot of times in my math lab, the x equal part will be there, but sometimes it won't, so pay close attention. If a is greater than 0, then the minimum value is y equal k. Okay, if a is greater than 0, the parabola opens up. So there is a minimum value. Remember, the y-coordinate, the functional value, that is the max or the min. Okay? The h, the x equal h, is where it is. The y equals k is what it is. And the second part of number 3, if a is less than 0, then the maximum value is y equal k. Now, if a is less than 0, that is the coefficient of x squared is negative, the parabola is upside down. And that's why you have a maximum value. And part D, here is our graph of a parabola with a greater than 0. We sometimes say the parabola opens up, the coefficient of x squared is positive, so it opens up. The vertex is hk. This dotted vertical line is the axis of symmetry. It's x equal h. Okay, and the minimum value is k. Notice this parabola doesn't have any x-intercepts. A quadratic function does not have to have x-intercepts, but it must have a y-intercept. Okay, all quadratic functions have a y-intercept. Remember, it's f of 0, and x equals 0 is part of the domain. But this one doesn't have to have an x-intercept. Okay, so this is the so-called right side up parabola. If we flip it over, okay, this one has a less than 0. So the coefficient of x squared is negative, so the parabola opens down. So the vertex, again, is right here, and this time k is a maximum value. And again, x equal h, that dotted vertical line, the axis of symmetry. Now x equal h is where the maximum occurs. K is what the maximum value is. Okay? So again, vertex at hk. I always label the vertex v as in vertex. Okay, and notice this one, it does have x-intercepts. and also it has to have a y-intercept. But remember, parabolas, quadratic functions, don't have to have x-intercepts. They do have to have a vertex. They do have to have a y-intercept. Let's graph some. So some examples. For each of the following, we're going to find the vertex. In part B, we'll find the equation of the axis of symmetry. And in part C, we're going to find the maximum or minimum value of f and state whether there's a maximum or minimum. You know, don't just say 3. Say maximum value of 3 or minimum value of 3. Okay, now we're going to use the vertex to help us graph. Okay, and when we're doing the graph, I'm going to kind of show you how you can get a second point kind of quickly and a third point kind of quickly. Now remember, in my math lab, you always must plot the vertex, and then you have to give at least one other point. And of course, you have to click the parabola icon before you start drawing it. So part A is vertex, part B is equation of axis of symmetry, part C is maximum in value, and part D is the graph. Here's our first one. F of x equals x minus 3 squared plus 6. Okay, if you compare this with the standard form, f of x equals a times x minus h squared plus k, our a is 1, our h is 3, and our k is 6. So the vertex is 3, 6. Remember, h is the opposite of what you see. I'm seeing minus 3. K is exactly what you see. Okay, the equation of the axis of symmetry, remember, it's x equal h. Don't forget the x equal. So it's x equal 3. If you just plop down 3, that's wrong. 3 is a number. It's not an equation. Okay, now do I have a maximum or minimum value? Okay, the coefficient of x squared is 1, so the parabola opens up. So that means I have a minimum value of 6. Okay, now we're going to plot the vertex. The vertex is at 3, 6 when we graph it. So I plotted 3, 6. Now, if you're going to graph it by hand, or if you're going to give it to my math lab, after you plot the vertex at 3, 6, go right 1. Always go right 1. And then you'll go up or down whatever a was. A was equal to 1, so I went up. If a were negative 1, I'd go down. If a were 2, I'd go right 1 and then up 2. Always go right 1. Now, by hand, to graph a second point from the vertex, go left 1, and then go up or down whatever a is. So from the vertex by hand, you will go left and right 1 unit, always 1 unit, left and right, then go up or down whatever the value of a is. Now, if you gave this to the graphing calculator, you would get the exact same thing. Number 2, f of x is equal to negative 2 times x minus 5 squared plus 1. Okay, again, if I compare this to standard form, our h is 5, our k is 1. So a vertex is at 5, 1. The axis of symmetry, remember, it's x equal h, so x equal 5. Now, our coefficient of x squared is negative, so the parabola opens upside down. So that means I have a maximum value of k, so a maximum value of 1. Now, again, if you want to see this on the graphing calculator, let me go ahead and take out our graphing calculator here. Okay, so y equals. Oh, by the way, this is the TI-84 plus C, which again you can download for free on the internet. Just go to Wabbit, okay, wabbitemu.com to download it. Okay, so negative 2, open parenthesis, x minus 5, close parenthesis, square that, okay, then plus 1, and say graph. Okay, there's our graph. Okay, now if we were doing it by hand, okay, you plot your vertex at 5, 1. You go right 1 unit. Remember, a was negative 2, so go down 2. From the vertex again, go right 1 unit, down 2, 1, 2. And then to get this other point, left 1 unit from the vertex, down 2, because a was negative 2. Now again, in my math lab, you got to plot the vertex, and then you may as well do the right 1 and then up or down a. That'll give you the second point, and you'll see the parabola start to take shape as you're moving around with your second point from the vertex. Okay, but again, remember, my math lab always wants the vertex. If you don't plot the vertex, it doesn't matter what you do next, it's going to mark it wrong. Number 3, f of x is equal to 4 times x plus 1 squared minus 3. Okay, comparing this to our standard form, remember, the h is the opposite of what you see. I see plus 1, so my h is negative 1. So my vertex is at negative 1, negative 3. Remember, going back to section 2.5, you're trying to figure out what makes the gadget in parentheses equal to 0. So x plus 1 equals 0 gives you x equals negative 1. So my vertex, negative 1, negative 3. The axis of symmetry is x equals negative 1. My coefficient of x squared is 4. That's positive. So I have a minimum value of k, so a minimum value of negative 3. And again, if we give it to the graphing calculator, just so you can see it, okay, let me clear that one out. Do y equal, okay, clear that one out. I have 4, open parenthesis, x plus 1, close parenthesis, square that, minus 3, and then just graph yourself to death. Okay, so there's our parabola on that one. Okay, let me clear that nonsense out, and let me close our graphing calculator. Now again, if we're going to do it by hand, from our vertex, negative 1, negative 3, we'll go right 1, up 4, left 1, up 4. Okay, so remember, left and right, 1 unit from the vertex, and then up or down A. So there's our parabola. So does this look like what our graphing calculator graphed? Okay, now again, here's our vertex, negative 1, negative 3, right 1, up 4, 1, 2, 3, 4. Left 1, up 4, 1, 2, 3, 4. Okay, now when you graph it by hand, please don't be afraid to go beyond those places that you found. Okay, just keep extending it. Don't just actually draw dots and say that's the end of it. Remember, we did have graphs that did not go on forever. Parabolas are not one of them. Okay, let's go to general form. So general form of a quadratic function. Okay, remember the standard form gave you the vertex. We need the vertex. So the form. What is general form? Recall, the general form of a quadratic function is f of x equal ax squared plus bx plus c. Okay, the a that's here, oddly enough, is the same a that's in the standard form. That is the only thing they share. We want to know what relationship, if any, exists between b and c and h and k. So the a in general form is the same as the a in standard form, which is kind of nice. The intercepts. The x-intercepts. Okay, recall, to find the x-intercepts, you solve the quadratic equation ax squared plus bx plus c equals 0. Now, if there is no solution to the quadratic equation, you don't have any x-intercepts. Now, if there's only one x-intercept, remember that's the discriminant equal to 0. If there is only one x-intercept, that actually corresponds to the vertex. The y-intercept. Remember, for any function, you evaluate f of 0. So for a quadratic function, in general form, f of 0 is the constant. Because you're going to have a times 0 squared plus b times 0 plus c. So it's the constant term in general form. If you have standard form, you actually have to do a little bit of work to find the y-intercept. So some examples. For each of the following, we're going to find A, the x-intercepts, part B, the y-intercept. Express your answers as ordered pairs. Now, when you're doing the problems in my math lab, be very, very careful. Sometimes he wants ordered pairs, but he doesn't say it. And sometimes he doesn't want ordered pairs, and he doesn't say it. I will always want ordered pairs. So our first one, f of x is equal to x squared minus 6x minus 16. Okay, for part A, the x-intercepts, you're going to solve x squared minus 6x minus 16 equals 0. Okay, to do the factoring, multiply to be negative 16, add to be negative 6. Looks like 8 and 2. The bigger has to be the minus. So x minus 8, x plus 2 equals 0. Then you set h factor equal to 0. From x minus 8, I get 8. From x plus 2, I get negative 2. As ordered pairs, 8, 0, negative 2, 0. So now if we were graphing it, we actually now have 2 points. Okay, part B was the y-intercept. Remember, for any function, it's f of 0. So f of 0 is negative 16. It's the constant term. You got 0 minus 16. As a point, it's negative 0, negative 16. Okay, number 2. F of x is equal to x squared minus 8x. Notice there is no constant. The constant is 0. Okay, for part A, the x-intercepts, you're looking at x squared minus 8x equals 0. Okay, on the left, I can factor out an x, leaving me x minus 8, so I have x times x minus 8. Okay, set each factor equal to 0. Don't forget the x. If I set x equal to 0, that's what I get, x equals 0. For x minus 8, I get 8. So I get 0 and 8 as points. Remember, those are the x-coordinates of the x-intercepts. So as points, 0, 0, and 8, 0. Okay, for part B, the y-intercept, remember it's f of 0, which is 0. So you have 0 squared minus 8 times 0. So as a point, 0, 0. Notice the origin is both an x and a y-intercept. General form is better for finding the intercepts. Standard form is better for finding the vertex, which then also makes it easy to graph. The connection between general form and standard form. Okay, so is there a connection? Recall, completing the square is the process that changes general form to standard form. When we did that process on a quadratic equation, we got the quadratic formula. Now remember, I am never going to hold you responsible for completing the square. I'm never going to make you do it. I don't even expect you to ever do it. I'm not going to test you on it. I'm not going to quiz you on it. I'm not going to make it appear on homework. If you read directions in my math or in the book that says solve by completing the square, solve it any way you wish. What matters is that you get the solutions correct. And the easiest way is either factor, use the quadratic formula, or if you have x squared equals a number, do the square root principle. So contained inside the quadratic formula is the relationship between h and ABC. Notice I did not say anything about k. The relationship between k and ABC is rather difficult, and I never remember what it is. I do, however, remember an easier way to find k, though. So, important points for a quadratic function. Points as in points to plot, you know, not important topics or something, but actual geometric points. X-intercepts. Okay, X-intercepts. Now remember, you don't have to have an X-intercept, though. So how do you find them? They're found by solving ax squared plus bx plus c equals 0. That's if you're given the general form. We would factor or use the quadratic formula. Or you solve a times x minus h squared plus k equals 0. This one would use the principle of square roots. Okay? So they're still not too bad. Finding the x-intercepts. Now remember, if the quadratic equation that you're solving does not have any real solutions, then your quadratic function does not have any x-intercepts. Remember, finding the x-intercepts, finding the zeros, solving the equation, they're all the same process. In either case, if there's no solution, that means that the function has no x-intercepts. Remember, a quadratic function does not have to have x-intercepts. It has to have a vertex, and it has to have a y-intercept, but it does not have to have x-intercepts. The y-intercept. Okay, the y-intercept has to exist. For any function, the y-intercept is found by evaluating f of 0, no matter what the function is. Evaluate f of 0. The same holds true for a quadratic function. Just evaluate f of 0. In general form, f of 0 is equal to c, the constant term. That's in general form. In standard form, there's no easy statement to say other than it's f of 0. But remember, there has to be a y-intercept for a quadratic function. There has to be. Just because it doesn't appear on the graph doesn't mean it's not there. Okay, it's just too high or too low. The vertex. This is the biggie. Okay. In standard form, f of x equals a times x minus h squared plus k. The vertex is always hk. Always, always, always. And I will always label the vertex v as in vertex. Now, it's in general form that there's an issue. So facts about the vertex. Okay? The facts about the vertex. The vertex is always hk. Now that's if you're using standard form. You get hk directly from the form. Now we're always going to call the vertex hk. So how else can we find h and k? It comes from standard form again. F of x equals a times x minus h squared plus k. Now, what if you don't have standard form? H is halfway between the two x-intercepts. Always. The x-coordinate of the vertex is always halfway between the two x-intercepts. So you're using half of the midpoint formula. So if the x-intercepts are x10 and x20, then h is x1 plus x2 over 2. That's how you find h. Now again, if there's only one x-intercept, that x-intercept is also the vertex. Now, this is how you find h. How do you find k? Remember, As an ordered pair, it's hk. This is an x, that's an f of x. K is equal to f of h, always. No matter how you find h, k is f of h. So this is why you hope and pray that h is an easy number, not just for graphing, but because you have to do a function evaluation. Now, when would you use this form? When would you use the fact that h is halfway between the two x-intercepts? If the quadratic function, for some reason, is given to you in factored form. Now you're probably thinking, that would never happen. You'd be surprised how often it does. So you use h as halfway between the two x-intercepts if you were lucky enough to get the quadratic function in factored form. H is equal to negative b over 2a. This is the ABC in the general form. So notice you would use h equals negative b over 2a if you had general form. Can you remember what is k? Going back up here, k is always f of h. So k is f of h, always, no exceptions. So again, you would use this if you're given general form. So if you're given general form, h is negative b over 2a. If you have it factored, h is halfway between the two x-intercepts, and k is always f of h. Now if you're given standard form, you can read off h and k. Let's try some examples. I've always called this everything you can do to a quadratic function except word problems, because if you notice, that's all that's missing. For each of the following, we're going to find in part A the x-intercepts. You're going to write your answers as ordered pairs. Part B, the y-intercept. You're going to write your answer as an ordered pair. You're going to find the standard form. You're going to find f of x equals a times x minus h squared plus k. You will then find the vertex. You will then find an equation of the axis of symmetry. You'll find the maximum value. You'll state whether it's a max or a min. And lastly, you will graph. Most of the time, before we do C, we do part D, because then you'll find the h and k, and then you'll be able to plug them in. Remember, A is the same A that's in general form. All of the real work is in A, B, and I guess technically C. Okay? I'm always amazed at the student that they can find C, but they can't answer any of the other questions. Okay, so let's try some. Here's our first one. I've got f of x is equal to x squared minus 2x minus 8. Okay. For part A, the x-intercepts. Remember, you're going to set x squared minus 2x minus 8 equals 0. I want to factor. Multiply to be negative 8. Add up to be negative 2. Looks like minus 4 and plus 2. Setting each factor equal to 0. That one gives me 4. That one gives me negative 2. As ordered pairs, 4, 0, negative 2, 0. Okay. Now, if we're graphing off on the side, off on your graph paper, you'd go ahead and plot 4, 0 and negative 2, 0. Okay, part B was the y-intercept. Remember, the y-intercept is f of 0. In our case, it's negative 8 as a point. 0, negative 8. Okay, for part C, I want to get the standard form. Since I got general form given to me, my h is negative b over 2a. Remember, this is a, b, c. So I'm going to have negative 2 over 2 times 1, which works out to be 1. So there's h. h is 1. Remember, k is f of h. So k is going to be f of 1. So I'm going to have 1 squared minus 2 times 1 minus 8. I get 1 minus 2 minus 8, which crunches out to be negative 9. So I've got my h and my k. My a, remember, is 1. So you don't need to write it. Don't put a 1 in front of the parentheses. So the form is f of x equals x minus 1 squared minus 9. Now you can verify that this is correct by actually squaring this stuff out and then subtracting 9 and see if it's the original problem. Okay, now that I've got my h and my k, now there was all the hard work right there. A, B, and C. Parts A, B, and C. Remember, part D was the vertex. Remember, the vertex is hk. So the vertex is 1, negative 9. E was the axis of symmetry. Remember, it's x equal h. So it's x equal 1. Don't forget the x equal part. Part F was the maximum or minimum value. My coefficient of x squared is positive. The parabola opens up. So I have a minimum value of k, minimum value of negative 9. Okay, now my graph is going to be on the next slide. So remember, from the vertex, your 1, negative 9, you would go right 1, then up 1. A was 1. Left 1 and up 1. But again, if you want to give it to your graphing calculator, so let's see, I'm going to have my y equal x squared minus 2x minus 8, and then just graph away. Now by hand again, remember, we're going to plot the vertex 1, negative 9, go right 1, up 1, left 1, up 1. Remember, we're going up 1 because of A. Now, does this look more or less like what our calculator drew? Let's drag out the calculator again. Do they look a lot alike? Well, except for the color, they actually do. Okay, so here was my vertex. Right 1, up 1. Left 1, up 1. Okay, let's try another one. Okay, I've got f of x equals negative 6x squared plus x plus 2. Let me go and warn you. It's going to be hideous. Okay, the numbers are going to be hideous. Our solutions. For part A, the x-intercepts. You're going to have negative 6x squared plus x plus 2 equals 0. Now again, I cannot think with a negative x squared. I can do this with the equation, but I can't do it with the function. I multiply everybody by negative 1. That'll give me a positive coefficient on the x squared. So that'll give me 6x squared minus x minus 2 equals 0. So I multiplied everybody by negative 1. I can do that with the equation, but I can't do it with the function. Okay, at factors, 2x plus 1 times 3x minus 2. I didn't have any choice for the 2 on the end. It had to be 1 and 2. And 6, I had a bunch of choices, but I could not put any even number here. So if you set each factor equal to 0, that gives me negative 1/2. This one gives me 2/3. Right, subtract 1, divide by 2, add 2, divide by 3. As points, negative 1/2 0, 2/3 0. Okay, I told you they were going to be horrible. Okay, they were going to be horrible. Okay, part B was the y-intercept. Remember, for any function, it's f of 0. F of 0 gives me 2. Remember, in general form, it is the constant. As a point, it's 0, 2. That one's going to be nice. Okay, part C was the standard form, so I have to find my h and my k. So I'm going to need a bunch of room, again, because my function is just so horrible. Remember, h is negative b over 2a, so negative 1 over 2 times negative 6. I get 1/12. Okay, it's horrible. I admit, it's horrible. K is going to be f of h, which is f of 1/2. So let me go ahead and show you something here on the calculator, something that you might find useful, something that you probably never knew the calculator can do. Okay, let me clear this out. Okay, I know I'm going to graph it, so let me go to my y equals. Okay, let me clear that one out. My original function is negative 6x squared plus x plus 2. Okay, now I can go ahead and graph it right now, but let me quit that for the moment. Okay, well, let's go ahead and graph it. What the heck? Okay, there's our graph. You're probably having a hard time seeing it. I know I am. Okay, but what I wanted to show you on this is most of us don't have any fun, have a lot of fun working with fractions. We hate to do it, and this isn't exactly a pleasant fraction to work with. I want to evaluate f of 1/12. Okay, we can actually do that on the calculator. Okay, the calculator will actually use the same math notation. We have to just know how to get the keystrokes. Okay, this key that's labeled VARS, VARS, that stands for variables. The y equals, those are variables, so hit VARS. You want the y variables, you want the y bars, so scroll over to that. Now, we want to do a function, so notice by default it is choice 1, so just press enter. Now you have to figure out which one of the y's did you put your function in. That's why I was put it in y1, so just go ahead and press enter. So now saying y1, and what do you want to do with it? I want to evaluate it at 1/12. Now, just like with function notation in math, we've put it in parentheses. Do it here. Open parenthesis. 1 divided by 12. Close parenthesis. And then just press enter. Okay, there's f of 1/12, this god-awful looking thing. Remember, I usually don't like mixed numbers or decimals, so to make this go to a fraction, hit math, and choice number 1. Enter and enter. So f of 1/12 is going to be 49 over 24. If we're going to plot this, this is where a mixed number might help. This is just a smidge over 2, right? Because 2 times 24 is 48. So this is 2 and 1/24. But anyway, this is how you make your calculator plot or evaluate a function. Like if I wanted to do y1 of 7, let's say. So let me do vars, y-vars. Function is already highlighted, so enter. It's y1, so enter again. Open parenthesis. What did I say I was going to do? y1 of 12? What the heck? And you get negative 850. Okay, if we were graphing it, I think that would definitely be off our graph. Okay, but anyway, this is how you can make your calculator do function evaluations, at least for numbers. It can't do letters. Okay. So, if we did this by hand, you're saying, gee, what would we do by hand? So I'm going to have negative 6 times 1/12 squared plus 1/12 plus 2. Okay, 1/12 squared is 1 over 144. So I have negative 6 times 1 over 144 plus 1/12 plus 2. Okay, I can do some canceling. The 6 can go into the 144. Now don't lose your minus sign. So I have negative 1 over 24 plus 1/12 plus 2. All right, 6 goes into 144 24 times. Okay, my LCD is 24. So negative 1/24 plus 2/24 plus 48 24ths. Negative 1 plus 2 is 1 plus 48 is 49. 49 24ths, just like the calculator gave me. Okay, right? Just like the calculator gave me. And you got to admit, what the calculator did was a whole lot easier. But there it is. Remember, we already did the graph. Okay. So let me quit all that. So I've got my H, I've got my K. I can now put it in standard form. Remember, the A is the same A that's up here, negative 6. So my f of x is going to be negative 6 times x minus 1/12 squared plus 49 over 24. Now again, it's true that if you square all this out, distribute the minus 6 and add 49 over 24, you're supposed to get the same thing. But you're probably thinking, I don't want to do that. Okay, neither do I. Okay. So we hope and pray that all this stuff was correct. I think I'm pretty good about that because I got the same answer the calculator gave. Okay. So there's your quick and dirty way to make your calculator evaluate a function. Okay, so where are we up to now? Part D, the vertex. Okay, remember the vertex is at HK. So my vertex is 1/12, comma 49 over 24. So there was my answer to C. Okay, part E was the axis of symmetry. Remember it's x equal h. Don't forget the x equal. So x equal 1/12. Part F was the maximum in value. Okay, my coefficient of x is negative. The parabola is upside down, which hopefully you remember that from the graph, from the calculator. So I've got a maximum value of 49 over 24. And we've already seen the graph on the graphing calculator. This is where if we were to do it by hand, it would be very, very tough. I doubt very seriously that my math lab would give you one this horrible, because to try to plot x equal 1/12 on that little bitty screen that's going to be in my math lab, that's just going to be next to impossible. So there. Now I would admit though, if you were trying to say what is the vertex, you probably would say something like 0,2 because it looks so close. But you now know it actually isn't. That's actually 1/12, comma 49 over 24. And if you look at that, yeah, it's just a smidge over 2, and it is just a smidge to the right of 0. But this should look more or less what our calculator would. Okay, remember, those two examples was everything you can do with a quadratic function except for word problems. So it's time for word problems. We'll be looking at what are called max-min word problems or optimization word problems. We're trying to optimize something. Now, what does that mean? The idea is that we want to make something as large or as small as possible. Now, you will see the max-min problems in their full glory should you go to calculus. We have to look at just special cases here, the quadratics. So we're looking for the vertex of a parabola. We need to decide which coordinate of the vertex that we're looking for. Are we looking for h or k or both? Sometimes because of the confusion with h and k, I'd like to sometimes say first coordinate of the vertex, second coordinate of the vertex. Okay, so you have to figure out, am I looking for h or k or both? H tells you the following. This is how you know you're looking for h. This is how you know you're going to look for the first coordinate. So it tells you these things. First of all, it tells you where the maximum or minimum value occurs. You're like, where is it? If you're doing time, it tells you when the maximum or minimum value will occur. Like, you know, when will you reach maximum height in your rocket? Another way of looking at where or when is what causes or makes the maximum or minimum value to occur. Like, you know, what rent should you charge per month in order to maximize your income? So what causes it to happen? So H tells you where it occurs, when it occurs, or what makes it happen. Now, what does K tell you? K only tells you one thing. K tells you what the maximum value is. You know, like, what is it? Like, what is the maximum income? What is the maximum height? Let's try some examples. Our first example. When the rent is $700 per month, all 200 units of an apartment complex are occupied. So it's kind of like they're all the same. For each $50 increase in the monthly rent, 5 units remain vacant, so they go unrented. What monthly rent will maximize the revenue? Okay, so we're trying to maximize the income. So it's $700 per month to get all 200 filled. And every time you go up $50, 5 units don't go rented. They remain unoccupied. So I'm going to let X equal the number of $50 increases. Because if you notice, I'm going up in $50 increments. So that's what I'm counting. I'm counting how many $50 increments I have. So notice if X is 3, the rent's gone up $150. But also notice, every time there's an X, 5 units remain empty. So if X is 2, 10 units are empty. Okay, now a little economics for you here. The revenue is equal to the rent times the number of occupied unit. Okay, and I'm going to call the revenue R. Okay, notice without any work from us, this is factored. Something times something. So it's factored. Okay, we didn't look for the function. We had to find it, and we're finding it in factored form. So we're going to use the fact that H is halfway between the two X-intercepts. See, our rent. Okay, it starts off being $700 per month. And then I go up, so I'm adding something. I'm adding $50 increments, and I'm going to have X of them. So the rent is going to be 700 plus 50X. Now, the number of occupied units, I start with 200, and I lose 5 every time there's an X. So it's going to be 200 minus 5X. So there's the rent. 700 plus 50X, 200 minus 5X. Now, don't do it, but notice, if you multiplied this out, if you did FOIL, there is a negative X squared term. The parabola is upside down. That means there is a maximum value. Again, don't multiply it out. It is factored. Again, no effort from us. It is factored. So we need the X that is halfway between the two X-intercepts. And notice, we know we need the X, the H, because we're wanting to know what will maximize the monthly revenue, what makes it happen. So let's set each one of these factors equal to 0 and solve. So 700 plus 50X equals 0. Okay, subtract 700. 50X equals negative 700. So X is negative 14. Now do the other one. 200 minus 5X equals 0. Okay, subtract 200. So negative 5X equals negative 200. Divide by negative 5. X is 40. Okay, X is 40. So those are my two X-intercepts. We need the one that's halfway between. We need the value of X that's halfway between. So we need X to be negative 14 plus 40 over 2, which is 26 over 2, which is 13. And remember what that means. We need 13 $50 increases. So the rent is going to be 700 plus 50 times 13. That's 700 plus 650, $1,350. So if you charge $1,350 under these conditions, you will make more money. You will have more income than if all of them were filled at $700. Also notice though, you've got, see, 5 times 13, you've got 65 empty units. It seems weird, but you can sometimes make more money by not filling everything up. Number 2, the other rocket scientist problems. So the height in feet of a projectile, t seconds after being thrown into the air, is given by that thing. S of t equals negative 16t squared plus 96t plus 15. Notice, the function is given to you. It's given to you in general form. When we found it in number 1, we found it in factored form. Okay, question A is how many seconds after being thrown into the air does the object achieve maximum height? And in part B, what is the maximum height? Let me go ahead and warn you. In my math lab asks the questions reversed. It makes you first find the maximum height, and then it asks you when does it happen. It's easier to do it in this order. What makes it happen, when does it happen, and then what is it? Because if I find out when it happens, I plug that value of t into the function. So be aware, in my math lab, the questions will be asked backwards. Answer them in the order that we're doing them, though. So our solutions. The maximum height, remember, is going to be t equal negative b over 2a. Okay, t is negative b over 2a. So I'm going to have, see, I've got a, b, c, so negative 96 over 2 times negative 16. So it's going to be negative 96 over negative 32, 3. So 3 seconds after you throw it into the air, it's achieved maximum height. Okay, now what is the maximum height? It's S of 3. So maximum height is S3. Now please don't just leave it like that, S of 3. Crunch it out. So I'm going to have negative 16 times 3 squared plus 96 times 3 plus 15. See, 3 squared is going to be 9, so I'm going to have negative 16 times 9, and 3 times 96 is going to be what, 288? Then plus 15. Okay, negative 16 times 9, negative 144 plus 288 plus 15. So it crunches out to be 159 feet. That's as high as this thing's going, 159 feet. And it'll do it in 3 seconds. So now you're a complete rocket scientist. Okay, question number 3. The monthly cost in dollars of producing X units of a product is given by C of X equals 0.02 X squared minus 600X plus 1200. What monthly production level will minimize monthly cost? Okay, this is called the cost function. Okay, in real life, when you try to find the cost function, you actually perform the experiment. You actually produce some units and then try to find a function that will model it. So we're trying to figure out what monthly production. We're looking for the X value of the vertex. We're looking for the first coordinate. Again, the function is given to us. It's given to us in general form. We have to use that negative b over 2a. So we need x to be negative b over 2a. So we're going to have negative 600 over 2 times 0.02. So I've got 600 over 0.04. Okay, and you would just take out your calculator and do the division. You got to make 15,000 units per month in order to minimize your cost. It seems weird. It seems like you can minimize your cost by not making anything, but it actually costs you more money to do nothing than to do something. Number 4. A rectangle in the first quadrant has one corner at the origin and the opposite corner on the line y equal negative 2x plus 10. Of all possible such rectangles, find the area of the rectangle that has the largest area. Now keep in mind that a square is a rectangle. Okay, this is actually what's called a packing problem. It's kind of like you're trying to figure out what is the largest package I can put in this space. And usually the space is some sort of weird shape and your package is some sort of a cube or a rectangular prism. Let's go and see if we can draw this. Okay, so on the board is a sketch of the problem. Okay, so our area is a times xy. Okay, now if you were in class, you would actually see the sketch of the problem. So I've got my x and y axes, and here's going to be the line y equals negative 2x plus 10. So the area is x times negative 2x plus 10, because how do I know it's y is negative 2x plus 10? It says so right there. Okay, y is negative 2x plus 10. Notice it's factored. Okay, we didn't do any work. It's factored. Okay, so we're going to need the x value that's halfway between the two x-intercepts. So find the x-intercepts. Don't forget the x equals 0. So x equals 0. The other one, negative 2x plus 10 equals 0. I get negative 2x equals negative 10. So x is 5. So we need what's halfway between 0 and 5. So 0 plus 5 over 2. I get 5 halves, or if you like, 2.5. The area, because we're looking for the largest area. 5 halves times negative 2 times 5 halves plus 10. Okay, the 2's cancel here. So I have 5 halves times negative 5 plus 10. Okay, negative 5 plus 10 is 5. So I get 25 over 2. So it's 25, or if you prefer, 12.5 square units. So there's nothing up here that says I can't use mixed numbers or decimals. Now, this is not a rectangle, right? Because x and y did not work out to be equal. Remember, this one was x. This one was y. The x is 5 halves. The y is 5. It's not a square. Okay, it's not a square. Now again, if you saw it on the board, because it says on the board is a sketch of the problem, you'd have your x, y axis. Okay, y equals negative 10. It's going downhill. It has a y-intercept of 10, and it just goes downhill and hits the x-axis at 5. Okay, number 5. A rectangular corral is divided into 2 smaller paddocks by a fence that is parallel to 2 opposite sides. If there are 600 feet of fencing available, what is the largest combined area that can be enclosed? So we're trying to maximize the area. We want to know what is the largest area. we're looking for the y value of the vertex. We're looking for the k. So the picture of the board is on the problem. Okay, this would be the picture. You're going to have a rectangle, okay, and then you're going to have a line in the middle that's dividing that rectangle into smaller rectangles. So I've got a rectangle that looks like this, and then a line in the middle. Okay? So the fence gives us, okay, I've got 600 feet of fence. Okay, now think about your rectangle. If I call the horizontal ones x, I've got an x on the top and an x on the bottom. And if I call my vertical ones y, you got a y on the right, a y on the left, and don't forget the y that was in the middle. So I've got 3 y's. So I've got 600 feet of fence. So 2x plus 3y is 600. Now if you made your rectangle like this and you divided it horizontally, you'd actually have 3 x's and 2 y's. It turns out it does not affect the total combined area of the largest such rectangle. It seems like it would, but it doesn't. Okay, remember area is x times y. Okay, remember I called my vertical one x, y, excuse me, my vertical one was y, horizontal one was x. So the total area is x times y. It's factored again. Okay, it's factored. Problem is, too many variables. I'm going to solve the fence equation for y. That way I can replace this y with something about x. So starting off with 2x plus 3y equals 600. Okay, subtract 2x. Divide by 3. So 600 is minus 2/3 x. Excuse me, 200 minus 2/3 x. If you're saying, I don't like the fraction, should I have solved it for x instead? You would still have a fraction. There was no way to avoid the fraction. So I can now write this in its factored form of x times 200 minus 2/3 x. Again, it's factored. We didn't have to do any work. It's because of area is length times width. Okay. Now, we need the x that's halfway between the two x-intercepts. So let's find the two x-intercepts. Okay, this one gives me 0. I've got a little bit of work to do on that one. So let's see, x equals 0, and then the 200 minus 2/3 x equals 0. Again, I hate the fractions, multiplied by 3. So I have 600 minus 2x equals 0. Subtract 600. Divide by the negative 2, so x is 300. Now remember, we need what's halfway between 0 and 300. So 0 plus 300 over 2, I get 150. Okay, that's x. Remember, this expression, that's y. So here is going to be 150 times 200 minus 2/3 times 150. Okay, let's be really lazy and let's just take out Mr. Calculator here. So I've got 150, open parenthesis, 200 minus, okay, 2/3, okay, 2 divided by 3, open parenthesis, 150, close, 15,000 square, what is this, feet? So if we do the crunching by hand, 15,000 square feet. And again, remember the picture that was, quote, on the board was we have a rectangle, an x on the top, an x on the bottom, a y on the left, a y on the right, and when we divide it into two smaller paddocks, I used a vertical one, so that gave me another y. That's why the fence was 2x plus 3y equals 600. Now again, if you say I want to divide it horizontally, you still end up with the same total combined area. Seems like it should matter, but it doesn't. That's the end of section 3.3.